So today we will be working with this grid and we will try and write a Python program which will check if this grid is actually a magic square or not. The condition to prove whether a square or a grid is a magic square is this. So all the sum of all the rows, the sum of the columns and the sum of the diagonals should be equal. So we will try and use this data and try and write a Python program. In the class today, I had written this much code where I had declared a grid with all the values as 0, and this part of the grid, this part of the code goes by each row and then by each column, and it asks for data inputs, and then it just inputs the data into the exact coordinate. So to write the rest of the program, I will deal with rows, columns in one part of the code and diagonals separately, because if you look at the diagonals, they are located at different coordinates. So we don't have to run the entire for loop for all going through all rows and columns for the diagonals. We can just have a simpler loop. So if you look at number 2, which is on the diagonal, this is the coordinate 0 0 because it's row 0 and column 0. Number 5 is 1 1 and number 8 is 2 2. Okay. Number 6 is the coordinate 0 2 because row is 0 and the column is 2. Number 5 is row number 1 and column number 1. Number 4 is row number 2 and column number 0. So this is how the coordinates of diagonals are going to work. So at the start of my program, I'm going to assume that magic square is true, which means it is going to be true. It's just an assumption for me. And then I will start writing the code for the diagonals. So I would say that sum of diagonal 1 is sum of diagonal 2, and I'm just declaring it to be 0 because I don't know what the sum will come out to be. Then I will run one for loop only, since we can just check it by the rows and we don't have to really deal with the columns. So for rows in range 0 to 3, because there are 0, 1 and 2, 3 rows in it. So the sum of D1 is actually the sum of D1, plus grid is the name of the grid, and I will just say rows. Okay, this is because the diagonal 1 is 0 0 1 1 and 2 2, so it will just take those values in there. Okay, sum of D2, I'm going to use a different logic out here. I will say that the sum of D2 is going to be grid. The first value can be rows, okay, and the second value could be 3 minus rows minus 1. So why have I done this? This is my diagonal 2. This is 6, 5 and 4. So number 6 is row number 0 and column number 2. Okay. So rows, if the value of rows is 0, so this will be 0, and 3 minus 0 minus 1 would be 2. So it will be 0, 2, which is the value 6. When I reach number 5, the row number is 1. So it will be 1 here, and then 3 minus 1 is going to be 1, which is this column 1, and so on. So it's basically just using this logic, we are actually going back by one column, like just going down by each column. Okay, so this is it, and then I just check the condition. I say if sum of D1 is equals to, or I would say rather sum of D1, if it's not equal to sum of D2, then my condition automatically fails, and I say that my magic square is false. It is not true. Okay, so this part of the code deals with only the diagonals. The rest of the code that I'm going to write is going to deal with checking the sum of the rows and the sum of the columns. So for this, of course, I need two loops because I need to go by the rows and columns. So for rows in range 0 to 3, I would say the sum of rows is 0 because I don't know what it will come out to be, and the sum of the columns is also 0. And then I start with another loop, which is columns in range 0 to 3. Okay, the sum of the rows is going to be the sum of the rows plus grid rows columns. I'll explain it to you just now. And the sum of the columns is going to be sum of the columns plus grid columns rows. Okay, So what happens is when row starts with the number 0 and columns is 0, then it's 0 and 0. Okay, and the sum of the columns, which is this, is going to be uh, column and the value row. So it's basically, if you see, the rows are this way horizontal and it's vertical, and that's why I've switched the values of columns and rows. So you just do a quick run of this. First start with the value of rows as 0 and then go by 0, 1 and 2 for columns, then increase the value of rows by 1 and then again go for columns for 0, 1 and 2, and then finally the rows becomes 2 and the columns will be 0, 1 and 2. So you check this out, just do a debug with this and you'll be able to figure out why I have written this. Okay, then once this loop has finished running, I want to check if the sum of rows is not equals to sum of the columns. Okay, and this condition can be checked even after one running of the loop, because even after once the loop has run and still this condition is not true, which means we don't really have to go further running the code. We already know that it is not a magic square. So if the sum of rows is not equal to sum of the columns and it is also not equal to that diagonal value which we calculated, any one diagonal is fine. You don't have to check for all two diagonals, even if it just does not match one diagonal, which means the magic square is false. Okay, so the code will run through first the diagonals. If the magic square is false, it's not a magic square, and then it will run this code. So if any of these two codes do not satisfy the conditions, the magic square is gonna fail. So all you have to do, if magic square value remains to be true, which means none of these conditions were met and the sums were actually equal to each other, then you have to print it is a magic square. Okay, otherwise print not a magic square. Okay, I think that's about it. So I'm going to quickly run this code. Now it is asking me for the data, so I will just go by 276,951 and 438. So 276,951 438. So 438. Okay, and it says it is a magic square because actually if you see all of the rows, columns and diagonals, the sum of all of them is equals to 15. So try running this code once again and change a few values to check that now the next run of the code should say that it is not a magic square if you change any of the values. Okay, this part of the code I would really say sit with a pen and paper and just calculate the rows and columns at each iteration of the loop, and you will understand why I have written this code and why these values are switched. It's just horizontal and vertical, basically. It's just that way. Okay, so that's about it. So you run this code, and this is the first part of the task that you have to do. The second part of the task is over here. This worksheet is shared with you already on the class stream. So you try that.